Let's take a look at the even problems on your practice in case you are feeling stuck or just want to see some more examples. For number 18, I take a look and I notice right away, look at this. I've already got a set of opposites, negative 3x and positive 3x. So let's take the equations just as they are. No need to multiply anything this time. And now let's add them up. Negative 3x plus 3x goes to 0. That's the whole point of elimination. 6y minus 10y is negative 4y's. And negative 12 plus 4 is negative 8. This is an equation we can solve. Divide by negative 4. And we end up with y equals positive 2. Okay, once you've got that, now go back. We know y is 2. You can use either of these equations you started with. Doesn't matter which one. I'm just going to use the one on the top. So I don't know x yet, but I do know y is the number 2. So negative 3x plus 6y equals negative 12. This I can solve. Multiply the 6 times the 2. Now let's do a subtraction of this 12. That's going to leave me with negative 3x plus 12 minus 12 goes to 0. That's the whole point. Equals negative 24. Divide by negative 3. We're left with x equals positive 8. So my solution is x is 8, y is 2, the ordered pair, the two numbers that make that true. Let's check it with a graph. Always type in your original equations, not the multiplied ones, the original ones. So there's the first. I hope they cross at 8, 2. Let's see, the crossing here is at the ordered pair, 8, 2. So we are in good shape. Next up, number 20. Now this almost looks like a pair of opposites, but it's not. They're actually the same. So let's take one of the equations. I'm going to choose the bottom one and multiply by a negative 1 on both sides of the equal sign. So the top equation is exactly the same. On the bottom equation, negative 1 times negative 6 is positive 6x's. Negative 1 times 10y is minus 10y's. And negative 20 times negative 1 is positive 20. Now these equations get added up. Negative 6x plus 6x is 0. That's the whole point we're trying to eliminate. 10y minus 10y is also 0. Okay. Negative 13 plus 20 is positive 7. All right, well, no variables are left, and that's a false statement. That just means this system of equations has no solution. Now we're going to check this with a graph. I should see two lines that are parallel, that don't ever cross each other. So let's make sure that is what happens. Going back to the original equations. And so there's the first. Now the second. Zoom in a little bit. Yep, this is just two parallel lines. They never cross, and therefore no solution to the system. Let's carry on for the next one. No set of opposites, so let's think a little bit. We could eliminate the x's by multiplying by a 2 and a 9. I think, though, I can take this 3, turn it into a 12 just by multiplying by a 4. Now, because I want to create a pair of opposites, I'm actually going to multiply by a negative 4 on both sides of this equal sign. That's going to take this minus 3y, make it a positive 12y, so that when I add, the y's should eliminate. Okay, negative 4 times 9, that's negative 36x's. Negative 4 times 3y, or negative 3y, is plus 12y's. 27 times negative 4 is going to be negative 108. The bottom equation, we don't need to change. Now we're ready to add them up. Negative 36x plus 2x is negative 34x's. 12y minus 12y goes to 0. That's the whole point. That's what we're after. Negative 108 minus 28, negative 136. I'm just going to double check that, though, on my calculator. Minus 28. Yep, negative 136. And so to finish, to get the number for the x, let's divide. Divided by negative 34 turns out to be a positive 4 for the x. Nice. At this point, I know what number x is. Go back to one of these original equations. Put that number in for the x. I think I'll use the bottom one. So where I see an x, I'm going to put the number 4. I don't know what y is, so it just stays a y. That's what we're trying to find. Let's simplify this first. 8 minus 12y equals negative 28. We want to get y by itself, so subtract 8. Subtract 8. That's going to go to 0. Negative 12y is equal. This will be a negative 36. Divide by the negative 12. Divide by the negative 12. And we've got y equals positive 3. Okay, so I think my final answer is x is 4, y is 3. Let's check it. On my graph, the original first equation looks like this. The original second equation looks like this. They cross each other at 4, 3, 4, 3. Looks good. And let's go one more time. On this one, there's no easy number to multiply 5 by to make it 6 or 2 to make it 3. Okay, we're going to have to multiply both equations this time. You have lots of choices. I like to keep my numbers small, so I'm going to take this top equation and multiply by 3. That would give me here, I'm going to eliminate the y's. So this would give me a plus 6y once I distribute. Let's actually look at how that plays out right now. 3 times 6x is 18x. 3 times 2y is plus 6y. 3 times negative 8 is negative 24. That means down here, I want to have the opposite, a negative 6y. So to turn a 3 into a negative 6, let's multiply by negative 2 and see what happens. Negative 2 times 5x, that's going to be negative 10x's. Negative 2 times 3y is minus 6y. And negative 2 times negative 8 is plus 16. So we've got our set of opposites. Now let's add. 18x's plus negative 10x's. 6y minus 6y goes to 0. Negative 24 plus 16 is negative 8. Divide to finish. Divide to finish. And x is negative 1. Now let's take that x value, go back to one of the original equations, pick the top one this time. Where I see an x, let's put the number we know x is, that negative 1. And figure out what the y needs to be. 6 times negative 1, we'll simplify that first. Let's, to solve, add the 6, leaving us with 2y equals negative 2. To finish a division and a division, y equals negative 1. Oh, look at that. So we think the solution should be negative 1, negative 1. Let's check it. Graph the original equations. See where they cross. They cross at negative 1, negative 1. We are in good shape. Give that a highlight, and we're all set.